This is part 22f1fa19c3h. This is line 22f1fa19c3h. Cauchy stress quadric Mohr circle plane load transfer 5G Wow Seti. Brazilian radio signal. And the keywords for Mohr circle method, we've been talking about this in the last 3 videos, so you want to go back 2 more videos, which would be G, H, F, G. Go to F. E or X, actually start at E. The E letter comes at the end of the number, so you can, it's alphabetical. So keywords from Mohr circle method, Google Cauchy stress quadric. So quotes from Wiki, Cauchy stress quadric. The Cauchy stress quadric, also called the stress surface, is a surface of the second order that traces the variation of the normal stress vector ON. This little guy here, as the orientation of the planes passing through a given point is changed. So here's a really big graph for you to look at. You see that? It's got all these degrees and stuff. It's hard to read. It's got those circles 0, 1, 0, 2, Tn, Tmax, 0, 1, 0, 2, Tmin. So maximum. And again, you go to Wiki, you can look at this. This is figure 8.3, transformation of stresses in 2 dimensions showing the planes of action of principal stresses and maximum and minimum shear stress. Okay, so here's another graph that came up. Figure 8.1, stress transformation at a point in a continuum under plane stress conditions. Okay, there you go. And the third one is this one here. And this is the figure 8.2, stress components at a plane passing through a point in a continuum under plane stress conditions. And here's another one here. P. P is the key there. See how there's a little circle floating in the square? Plane stress state and continuum. Plane strain. Our main article, infinitesimal strength. Again, this is from Wiki. I forgot to put that there, okay? Actually, I better do that now, because if I blog it and don't have it, I'm in trouble. So plane strain, main article. If one dimension is very large compared to the others, the principal strain in the direction I haven't even eaten, I'm still having problems. The principal strain in the direction of the longest dimension is constrained and can be assumed as 0, yielding a plane strain condition. Figure 7.2, which I probably don't have up there. In this case, though all principal stresses are non-zero, the principal stress in the direction of the longest dimension can be disregarded for calculations, thus allowing a 2-dimensional analysis of stresses. A dam analyzed at a cross-section loaded by the reservoir. Load transfer. The evaluation of loads and stresses within structures is directed to finding the load transfer path. Loads will be transferred by physical contact between the various component parts and within structures. The load transfer may be identified visually or by simple logic for simple structures. For more complex structures, which is what you'll be making, you need more complex methods, such as theoretical solid mechanics, or numerical methods may be required. Numerical methods include direct stiffness method, which is also referred to as the finite element method. The object is to determine the critical stresses in each part and compare them to the strength of the material. See strength of materials. For parts that have broken in service, a forensic engineering or failure analysis is performed to identify weakness, where broken parts are analyzed for the cause or causes of failure. The method seeks to identify the weakest component in the load path. If this is the part which actually failed, then it may corroborate independent evidence of the failure. If not, then another explanation has to be sought, such as a defective part with a lower tensile strength than it should, for example. So here's another graph here. Plane strain, state, and continuum. Okay, so at the end of that video, we're going to go on to the next one.